Hey guys, welcome to Craft versus Cruft. I'm Ray Myers. I'm a site reliability engineer at Morningstar, and today we're going to refactor a donut. This original code is from an old blog post by Andy Sloan, and it's really interesting. Today we're going to attempt rather foolishly to maintain it. So let us let us say that we actually work on this code. We're needing to maintain it, and we've just gotten a request from a customer, and they've asked us to add a feature. So let's look at what this does now. Let me show you. It's really cool, actually. So we've got in the README here the build instructions. It's got some warnings, but it appears to build. That's nice. And then we can run it. And there's a little spinning 3D donut. How cool is that? So this is really cool, but we've just gotten a feature request that we want to be able to insert a command line argument that will make the donut bigger or smaller and take up more or less of the screen. Whereas right now it's just always the same size, no matter how big or small your window is. So cool, that sounds pretty easy. So, let's just pull up the old source code and see what we're looking at. Oh crap! Well, this is going to be harder than we thought, but fortunately, we have our powers of refactoring. And so I will attempt to make some sense of this to where we're able to work on it and make changes to it. And we might not understand all of it. There's some trigonometry in here, and it's been a long time since I took those classes, but we'll at least get this into a more workable state. And while this is completely a toy example, the techniques we're going to use are absolutely valuable on real world situations. I do these at work all the time. So let's get started. So the first thing I'm noticing is that the formatting of this file is completely off, and it has been contorted into a donut. So I think the first thing I'd like to do is run a formatter on it, and we'll see where that gets us. So Clang has a formatter for C that's pretty decent. I'm just going to go ahead and use that. See where we get. Okay, that's a little better. So we've now got somewhat legible. I mean, I wouldn't call this maintainable code, but we can at least see that there's some loops and a main method and things going on. So that is first part of de-obfuscation. And I'm just going to commit right there. Actually, I'm not going to commit yet because I haven't verified that it still compiles and runs, which you would think that a formatter wouldn't break it, but I've seen it happen. So great. Now, if we make any other change, we can always roll back if we've broken it. Next thing I see is, as you often do, some comments that aren't particularly useful or up to date. Let's just get rid of those. Let's just get rid of those comments. And I see some other useless code there. This looks like an indentation problem, but actually this outer for loop just doesn't have a brace, so the indentation looks pretty correct to me. So we've gotten rid of some comments. Still works. And Let's see. Kind of go where our heart takes us here, because I cannot yet understand this code well enough to know what in the heck I would do to make the change that the customer has requested. I can see that there's an interesting white spacing issue here where there's like an escaped new line in the middle of a name. Roll that back. But I'm also noticing we've got a lot of declarations done on one line. So I think we can also, this would be more readable if we didn't have that. Consult your team's code standard as for whether that's a good idea or not. People differ, but I think on this particular code, it would be easier to manipulate if we didn't have multiple declarations on the same line. So I'm just going to collapse all those. And this is an example, we'll see many, of what's called a provable refactoring. All the changes that we're going to make up until the very end here are changes that, if you perform them correctly, shouldn't be able to possibly change the behavior of the code. So if it builds, hopefully it'll do this the same thing. We're going to try it out anyway, but getting a really good handle on provable refactoring is a great way to start being able to improve code bases where you don't have strong unit test covers to build on, as is the case here. So let's just collapse these. Another one we're going to use a lot in the provable refactoring department is rename. We'll do a lot of renames, and then method extractions. You get a long way with those. So we've broken those out. We've got all these C and D, all these single letter names, no good. Cannot tell what that's for at all. L is an especially bad variable name because I can't tell if it's an L or a 1. So again, starting to get a little more legible, but not to the point that I really have any idea what's going on. But often that's the case, you know, when you come into a code base. Just a few more. These variables, these are ints. I should say, by the way, that if you're not very familiar with C, if it's not your dominant programming language, not mine either. I haven't done pure C since college, so there are probably a lot of best practices things that I'm not going to pick up on. I'm just going to apply normal logic of code readability. So still works, and we've broken out all our declarations. I see that there's a declaration up here that appears to be there for no good reason. Where is K actually used? K is only used in this for loop here, and it's not declared with any particular type, so that means it will default to int. So let's declare it where it's used, minimize the places where it's in scope to only where we need it, and then declare it explicitly as int. I don't think it is a good idea to ever have these implicitly take a particular type. Similar with main. The return type of main is int. All right. Good, good. So what else do we see? I mean, we have an implicit declaration of the math libraries. Really, this should be done with an import, and that would get rid of the compile warnings. So let's see what all the compiler warnings are. We have an implicit declaration of memset, which is in studio.h. We have string.h, and Yeah, let's see if we can get rid of the warnings. That's a nice case of static analysis. And in fact, there are some additional, if I can remember the GCC command line arguments, while would give us more warnings, but looks like we've only got the default warnings available. So let's do that. That would be slightly better. Practice, consult your... And that is a pre-compiler directive. And then we just need string.h as well. All right. Thank you for bearing with me there. All right. So the compiler no longer griping at us, and I believe we can take out that implicit declaration of sine and cosine now. So that's a minor improvement. What have we done here? We haven't committed our change. So we have a clean build and it runs okay. We'll go ahead and commit. Now, I'm noticing some more cases where things are declared far away from when they're used. This for loop is the only place I is used, and J. So we can get rid of those declarations, pull them, because, you know, state is messy. You only want state in the narrowest area where it's going to be used. Still working? Yeah, I think that's about all we can do on that level. The next thing I'd like to focus on is I'm seeing a lot of magic numbers. And it's not really clear what any of these do. 1760, what's that? Why? What's a 7040 doing here? What's 6.28? This is all doing me no favors in knowing how to interpret that. So I'd say the next rule I would try to apply here is no magic numbers. And after that, we've given these magic numbers names, then we can start to evaluate what about the names of these variables and what should they really be called, and then we can get something we can start to read. It's also going to confuse me that we have this no close brace here and no open brace on this for loop. People vary on whether they like to always include the optional braces, but I happen to. So I can see that indentation is correct. This one's a one-liner, doesn't bother me as much. So, again, still in a good state. So 1760, this appears to be a good old-fashioned char buffer because we're doing a put char on it being iterated over. And so that must be where the donut is being, written to and then displayed. So that means this must be the size of the buffer. So what's a good name for a size of a buffer? I'll go with a buffer size. Probably could be a size t, which is like an unsigned in, right? That'd probably be the right way to do this. But for now, although this is one of those things that eventually will need to take on many values, at least now we can give it a name, and everywhere it appears, it'll appear by that name. And we're out of 1760s, but we do have a 1761. So that's buffer size plus 1 is greater than k, or really that's k is greater than or equal to buffer size equivalently. Still good? Still good. Okay, so we'll commit after we've done some more renames of constants. Now, there's this other buffer that's being initialized, or this mem set is being done on it, but not with 1760, with another number. And I notice it's another type. It's a float instead of a char. So floats are typically, I guess it can vary, but typically 4 bytes long in C. So I wonder if there's a numerical relationship between this buffer size and this 740 magic number, and we can get rid of that too. So 740, 1760, indeed, it is a factor of 4 different. So that means we can just say buffer size times 4, and now that's one less thing that's dependent on a magic number. If buffer size changed, that would change with it. That's good. Even better, I believe there's this size of thing in C. And if we say size of float, then it'll do 4. Yeah, okay. So that's a little better. One down. All right, here's another magic number, which is 6.28. Let's come back to that. Not immediately clear what 6.28 is. Now, what is 0.07 and 0.02? Well, J is and I are just going from 0 to 6.28. So presumably it's just the size of the increment that they're going to travel on. If it was a different number, like let's say that these were both 0.2, then it would probably just, yeah, it just rotates faster. So that's kind of a to taste thing. But we don't have to leave it there. We can give it a name so it's more clear what's going on, and it's easier to modify as a parameter. So we can say this is J step. It's the amount that J will step by, and that's a constant. Suppose this is a constant too. And similarly, we can have an I step. So skipping that, still in a good spot. These others is 40, 30, 12, 15, 80. I'm seeing 80 a lot. These others don't really repeat much, but I'm seeing 80 a lot. And one of the places that I see it is a modulo on the buffer size. And from experience, I know that when you modulo a buffer size in order to know when you're printing it, where you're printing a character, then that is the column width of the screen. 80, I suspect, is the column width of the screen. So how could we confirm that? We know the overall buffer size is 1760. So I suspect that is divided into groups of 80, rows of 80. And so does this go evenly into that number? And then what does it leave? It does go evenly into it, and it leaves 22 as the height if the width were 80. Does 22 appear in our code? Yes, it does, and it is the range of y is going from, y goes from 0 to 22, non-inclusive. And x goes from 0 to 80, non-inclusive. So I think we've discovered a little bit more. And we have, and this will be relevant to making our feature change here. We know that the width is 80. And the height is 22. So let's just do a little replace. I'm using a /b regular expression to make sure it's the entire number that I'm replacing. That's going to now be width. I suppose I could use uppercase because it's a constant, but I'll leave you to debate the pros and cons of those variable name, constant name conventions. Great. So then 22. Don't want to replace that one, but I'll go back to it. There. Only showed up one place, oddly, but I kind of think it'll come into play more. All right. So does this still work? Yes, it does. Great. Notice 40, now that we've extracted out 80. 40 is half of 80. And that wouldn't really be enough to say that that definitely is intended to be half the height. But I noticed that it's being set to x, which traditionally would be the horizontal coordinate. And so we must be starting out in the middle of the x-axis here. So I do think that this 40, the intent of that is width over 2. Which logically would mean that is this half the height? Well, half the height's 11, and that's 12. I don't know if that distinction is important, but just to maintain the previous behavior, I do believe it is intended to be related to this. But let's just say that height over 2 minus 1 is what we'll use there instead of 12. And that way we can have it expressed in the form of something that has meaning and not just a magic number. Good. These other numbers aren't very significant to me yet, but this string, this is a constant. This is a magic constant. What's its name? Well, if we look at this donut, we can see that those are exactly the characters that are used to draw the donut. And they're different levels of shading. I think the author originally used the term luminescence for this. That's all well and fine. I do not know nearly enough about graphics programming to have any business using a term like luminescence. So I'm going to say that these are the shade cars. And that is a const char star. Very nice. So that is about, well, it's almost all of the magic numbers I can pull out of here. We've got some characters here. Like this 10 being used in put char. It's either going to use what's in the buffer, or if k modulo width is, I guess it's being coerced, an integer is being coerced into a boolean there, is either 0 or it's 1, and if it or non-zero. If it's non-zero, it's going to look in the buffer, and if it's 0, it's going to do this. What is 10 in ASCII? Let's take a look. Been a while for me, right? Ah, that is a new line. Well, that makes sense. So and then let's just be extra pedantic about this no magic constants thing, just to make the point, and throw that up there. And now we know it's not the number 10, it's a new line. is being done there. Everything's still working. And there's one more character constant when we were doing this mem set on the buffer. And 32, that one I do know, that is a space. And I think that is pretty descriptive there. It's not very descriptive as a 32. All right, a lot of great changes there. Extract constants. So, and then there's a couple of other magic constants here actually, and these, if you look them up, are actually control characters, and one of them clears the screen on a terminal and another one of them will bring the cursor to the beginning of the line. And so that's what's going on with these. You definitely could extract those out into like a pound define macro or a method if you wanted to do that. If it weren't clear, as it's not clear to most normal humans what that would be. I definitely had to look it up. So let's look now that this is a little more comprehensible. What's going on with these? Like, what are these two variables that are going from 0 to 6.28? What happens to them? Well, they get passed to sine and cosine, and then a bunch of things happen to the results of those. And so that would indicate to me, if you recall your trig, it's been a while for me too, that these must be angles. Because that's what you take the sine and cosine of is angles. And particularly, these must be angles in radians, because that is the format in which sine and cosine in math.h will accept, which means that this must be 2 pi, because radians go in 360 degrees in radians is going from 0 to 2 pi, or sometimes from negative pi to pi, but the cycle of it is 2 pi. So that means two things, right? One, we now know a little bit more about what we can call these variables. We also know what this 6.28 thing is. 3.14 at the beginning of pi, and then times 2 is 6.28. It's not exact, but it's exact as it needs to be for this kind of low-res operation for sure. So let's just call it 2 pi so it's clear what's going on. And this is like super pedantic, but when the code says that, then you don't need to write comments saying this is going from 0 to 2 pi, because it's clearly going from 0 to 2 pi. I also am not a particular fan of that they're using the constants on the left-hand side of all these comparisons. I'm always used to a for loop being like, the middle clause of it being, and j is less than this bound, not the bound is greater than j. That looks really weird to me. I don't know about you. So I'm going to shuffle that around here, make sure commented the wrong message here. We'll fix that in a minute. We'll just amend it. No worries. Actually, we did extract more constants there, so actually that's not a big problem, but I could do, if I committed by accident, that to update my commit. So these are our angles. Now, after talking to my product owner, I've discovered that the conventions that they would do in order to describe a couple of angles would be to call them theta and phi, and not just I and j. So we're going to do some renames, but If I just change it in one place, it's not going to change it everywhere. And in a modern IDE, in most typed languages, it would have like a right-click rename option, which I definitely recommend using in any situation that supports it. However, we're just in a text editor right now, so we're going to make do. And I'm going to use a regular expression with a word boundary indicated on either side in order to catch all references to a variable named I and sort of visually check and make sure that's all I'm catching. And I'm going to rename I to theta. And similarly, I step should now be theta step. And I'm going to name J phi. That is conventional to make trigonometric variables that indicate angles named with these Greek letters. All right, and then of course for consistency, J step should be phi step. Make sure we've done all that correctly. Oops. Yep. Now, that doesn't buy us much in and of itself. But now we can start to rename these other variables, because a lot of our problem about understanding any of this is that these all have these arbitrary single character names. And other than X and Y, almost none of them indicate anything. So what is C now? Well, C is the sine of theta. So I'm going to rename C to be sine theta. D is cosine phi. Ah, something's gone wrong. This is why we commit frequently, huh? Ah, you see what's happened? It renamed an uppercase D because I didn't have case sensitivity selected. Very important. Great. So then we've got these things A and B, which seem to be main variables that get incremented periodically, and I don't have anything better to call them. Let's just let them be A. But then E is the sign of the current A value. We can at least make that something comprehensible relative to the domain. Good. F is not F. F is sine of phi. G is cosine of big A now. All right, H being cosine of phi plus 2. I'm not really sure what to do with that, so I'm going to leave it be. D, also unclear to me what that's going to be. L, though, is cosine of theta. we've got a warning back in how we're initializing this because it's a single character. That should be const char new line. Const char. Yeah, good. Still worked, but we keep our warnings low. Then X and Y are pretty good. I don't know what T is. I do know M and N can change to being cosine and sine of B respectively. So let's just do that. That's why we got to check when we're not using an IDE assistance there, that we're not replacing a little more than we intend. Good. So we've got a big rename commit to do now. And you can see that these start to look a little bit more like if you were actually doing calculations, the equations you'd write. And they'd be a little more relatable to me if I remembered enough trigonometry to actually know what was going on here. And it is in 3 dimensions, so it is rather advanced stuff, but at least it's not through an extra level of obfuscation of variable names that have nothing to do with each other. So, what else can we do here to improve the situation? Well, B is not a B, it is the buffer. So let's call it that. Great. The Z, your guess is as good as mine. It's a big array of constants that is used in the calculation somehow. I don't really know what else to call it, so I'm just let that ride. I do also think the fact that this is all in one main method is becoming a low-hanging fruit here, now that we've gotten the variables at least handled the best that we can. So let's see if we can do something about that. Oh, and incidentally, we established earlier that buffer size is a function of width and height, so we don't actually need a separate constant for that. We can define it in terms of the other. So, what are these concepts? We've got something that modifies the current buffer, and then we have something that displays the current buffer. So let's extract a method. Yeah, display it'll need some arguments. We'll get to that. Looks like we'll need a buffer size, a width, and new line is, I guess, only used here, so that can be in here, or it could just be up here, whatever. but we will need the char buffer. And really, buffer size is a function of height and width, so it'd be more sane to just pass in the height and width both. Then we can maybe those should both be size t's, right? Seems reasonable. Okay, let's see how we did on that method extract. We did not actually declare this yet. Pass this in as a char star, and got to pass in the arguments. This is where an IDE that could just extract the method would handle all this for you. Great, and one more method we can extract here. There we go. It's that. Yeah. So we're iterating on the buffer somehow. Now, at least we're going to need these two things. But then it looks like we'll also need A and B. Those are floats, not ints. Pass in A, pass in B. A lot of parameters, but oh well. What has gone wrong? Well, it uses some constants. Generally, not too bad to declare constants. Up here, it's not a global variable, it's a global constant. Similarly, 2π, that is unlikely to change. Shade cars, yeah, I'm fine with those all just being constants of the universe here. All right, and we're also going to need float star z. All right, what else are we missing? Buffer size is undeclared. Well, again, we've passed in height and width, so that's something we can just ask about. Got some indentation inconsistency there. All right. Pointer from integer without a cast. So I think there's a... Is this not declared in the right way? Where does it think we're... There we go. So we've extracted those methods, and now it's a little more conceptually broken out. You can see in main, what the general flow of the program is without having to immediately get into all the details. So I think this is a good improvement. Let's commit it. No shame in if you try out to extracting some methods or a different structure and you just decide actually it's not any more readable. Yeah, just roll it back. That's fine. But in this case, I think that it is a good option. It's a little weird that we've got one print outside here and one print inside there, but I'm not too worried about it. If that bothered us, we could just take that out and put it in between these. So something I'm noticing when I think about these functions as an interface to the world is that buffer, height, and width got passed around together in both of these cases, and they're kind of conceptually grouped. If this were a larger system, they'd probably be constantly passed around together. And so I think that those would be a good candidate to extract a parameter object and use composition to make this just one thing that you pass around. If we're using an OO language, you might also want to give that behavior. I'm not sure about that, but at very least, this seems like a good opportunity for a struct in C. We'll see how much I can remember the syntax here. And what do we want to call this object? Let's just call it a canvas for now. And it has these things. It has a buffer and a height and a width. All right, let's just make sure I got the syntax right here. Yep. Good enough. So now, instead of declaring these three things separately, I can declare a struct canvas. And just declare it like that. Will that make an instance? And then okay. All right, no syntax errors. That's good. But now we're not using it yet. So we now don't want to use buffer in any other place other than where we've just put it into canvas. So let's pass the canvas in here. And no buffer, no height, no width. Just canvas. Not sure if we would need a struct keyword here or not. We'll see. And is it just canvas dot with the do? Parts of it, I think so. see if we've missed any instances of width. Yeah, a couple. Okay, that's all that. And then what about height? What about buffer? All right, we'll see how we do. Unknown type name. All right, so that apparently would get declared as struct. And our mem set also needs to use that. Great. So I think that is a good improvement as well. And the more we pass that around, the better that's going to help make it clear what's going on. So extract canvas struct. See, this is also called a parameter object. And in IDEs, you'll have the option to extract a parameter object sometimes. Now, what if we tried at this point? Because albeit I don't completely follow everything that's going on, this is drastically more maintainable code. What if we tried now to say, you know, the width is now 100 instead of 80, or, you know, it's 120. Would that work at this point? Would we be able to do what the original request was? All right, well, kinda. It now is oscillating closer to the middle of the screen, so something changed, but the actual object itself is not. So if we start to look at these numbers through trial and error, we could start to see, you know, if we started to change a couple of different things, what would happen? What if this 2 was a 4? All right, out the gate, we now have a bigger donut. So what if it were the case that this was expressed as a ratio? So we know if the width is 80, that 2 is a decent amount. So I don't know what exactly to call that. Maybe like outer size. A name is better than no name, so you can always change it later, but err on the side of giving it some kind of name, even an imperfect one. And let's say that this is a function of the canvas height width divided by 40. That's somewhat reasonable. This would be a float, though. And to avoid an integer division issue, I'm going to make that a float as well. So yeah, that's kind of nice. Now, if I have a larger width, I probably want a larger height as well. So let's just resize that. Yeah, okay. It's having a little trouble with my console. Maybe that's a little too big. Great. So that's now we have this, the height and width able to vary, and the size of the donut will vary with them because we've unified these parameters and expressed them in terms of each other. We were able to make that change. I'm going to commit this. making the donut bigger, and it should be clear now that we have these extracted out here and then passed in, that we could trivially make these command line arguments. So you've now seen a code base, albeit a small one, changed from complete incomprehensibility to relatively serviceable using only provable operations. And always remember what Lao Tzu said in Tao Te Ching: with patience, the most tangled cord may be undone. Thank you very much.